Hello, I'm Young Park. This video is for demonstrating assignment 1, which is dimensionality reduction using PCA. Without further ado, let's look at the code. So I load the data using scikit-learn datasets, fetch OpenML. You can see the MNIST data. I check the directories. It has data and targets, right? And I also check the shape of the data. It has 70,000 row and 784 features, because it is 28 by 28 pixel image. And also I used the train test split. I chose the test size to be 1/7, because it's 70,000 data and we want 60,000 of training data sets. So here I display the each digits. This is not all of the data, but this is a sample of data that I use here. NP where when the train when is equal to I, it's going to be 1 to 9, and yeah, we reshape the image, reshape the dataset, which was 784 features dimension to 28 by 28 to the dimension here. And then yeah, using PCA, which is principal component analysis, we will get the principal components first and second, and its variance ratio. Since principal component analysis is finding those components, principal components, and the best principal components has the biggest variance ratio. So you can see here the first principal components has the biggest, and the second is the next biggest variance. Explain variance ratio. And here is the principal component, first one and the second one. Here I projected the dataset into the hyperplane of first and second principal components. Then you can see the data over the plane. It's projected. Yeah. And I use the incremental PCA. It's about when it comes to really big data sets, you can't really do PCA because it gets really slow. Then you make mini batches, then you do the PCA each batches. Anyways, here we did the 154 components in 100 batches. It took around 1 minute. Anyways, so the reduced training data will be transformed by this incremental PCA. And yeah, using inverse transform, we kind of recover the image. Still it is compressed. So we can check the compressed image, and here is for the comparison. It's the original image, and this is compressed image. You can see. Use the recovered one. And question 2 is about Swiss roll dataset. We generated Swiss roll datasets like this using scikit-learn datasets as well. Yeah, it looks like this. It looks like a roll. We will be using kernel PCA. It's about transforming this data into feature dimension, yeah. And then you do the PCA projecting the data. Anyways, there is 3 kinds. There are actually 4. We cover 3, yeah. Anyways, there's linear, this is Euclid, RBF, and this is sigmoid, and there's gamma hyperparameters. Yeah, this is the results of the projecting using each parameters. So it's hyperparameters, so we need to find the best parameter. We're gonna be using this grid search, and then we'll check the performance by classifying using logistic regression. So we made the for the classification, we made the pipeline. So we'll do processing with the kernel PCA, and we'll be classifying the data using logistic regression, and we make the parameter grid, and we'll be doing the grid search using the grid. Right. So we fit the data. So, and then we check the best hyperparameters, which is gamma will be this value, and RBF, which is Euclidean kernel, is going to be the best performing. And the performance mean square error is like this, 33. It doesn't look so good. And then we projected, we plot the projection here. And here. Thank you for watching.